get going. Alrighty, right. Okay, so today I thought it might be kind of fun to just kind of start off with a very, very simple review of what we went over last week. I want to try something new this semester that I hope is going to work. I'm going to need your feedback to let me know if it's actually working and integrating into your own local game development projects. So if you go into the week 7 module, I've provided you with all the scripting stuff that we went over last week, and here's why I'm not sure if it's going to work yet. So if you click on it, it's just an HTML page. I'm hoping that you should be able to go in and copy and paste all of this stuff into. Does it work? Okay, great, wonderful. So you should be able to just go copy and paste all this stuff into MonoDevelop and continue working with the scripts. And I think maybe we'll just start off with reviewing what this looks like. So at the very least, you have some actionable understanding of how these components work together. Therein lies the big challenge when it comes to working with scripts, is understanding how all these little code snippets work together to produce an action inside the game. The connections between them is the hard part, okay? And once you understand the connections, we can start plopping them in pretty quickly and making stuff happen in front of us, all right? So here we are. This is our scene over here in the Unity, okay? And let me just play the scene real fast to get everyone up and running and super comfortable with what we've created. I've just put a little red box here. That red box is going to come back in a second. But at the moment, there's nothing, not a single thing inside of our world that is going to stop me from falling off the edge of the universe, right? So we need to generate some sort of death zone, some sort of event that allows us to both understand or have the computer understand that we have passed over a death zone, that we are dead, if you will, and that we need to be respawned and placed back into our scene. And we're going to do this with a whole series of triggers, right? Some colliders. Believe it or not, this collision system inside of Unity is a great way to pass information between different game objects. And let's just look at it real fast. So the first thing that we need to create is what? A collider, absolutely. Now, in the grand scheme of things, what is a collider? Is it a game component or a game object? It's a component, so it's a piece. It's a piece of a much larger object itself. So in order for us to very quickly go in and create this component, what do we need to generate first? An empty game object. You got it, right? Since a collider is a component, it needs to sit on something. And Unity allows us to do this pretty directly with the game object pull-down menu, and I'm just going to say create empty. So let's just do it. I'm going to name this thing Death Zone. There we go. I'm going to reset its position so that it's centered inside the scene. Now, with that game component selected, I can fire off the move hand or the move tool to get a really good visual understanding of its current location inside the scene, which is at the origin. Now that we have a game object, let's add the component, okay? And I'm going to do this in the inspector. However, there's a number of different ways you can do this. I like the inspector method, but it's just me, okay? So add component, it's under physics, and let's just do a simple box collider, okay? Now, Unity does a great job of visualizing our box colliders with this little green box. You can see it right there inside the scene itself. It's a little small, so let's make it much larger. I'm basically going to create a platform that runs under the entirety of my little cube here, my little plane. And oops, I deselected my death zone, many apologies. And I want to make sure that's sitting underneath my plane, with the idea that if I walk off of it at the moment, so if I walk off the edge, woo, bonk, I stop on the collider, okay? Let's do this. This might help, okay, just to understand specifically what we're working with. If you notice how I've created my Unity scene here, or how I've changed my Unity editor, I have my editor on top, my scene view, and then the game view is kind of tucked over here into its own tab. This is actually probably a really cool thing to do. I'm going to take my game tab, and I'm going to bring it downstairs. Okay, that way I can have my editor view open on the top, so I can see precisely what's happening in the editor and what the player sees as well. And this is actually kind of cool. I'm going to select my first-person controller prefab just for a second, just to get a good understanding of where it is. Now watch this. With my first-person controller prefab selected in the hierarchy, when I play the game, now we can actually see, if you check out the top half, we can see exactly what the game is evaluating and generating. So I can walk off, and I can see that my guy is just static on that collider. I can even walk underneath it, which is kind of fun. Now eventually, if I walk far enough, I'll walk off of that collider. Yep, there it goes, and I'll start to fall. So what's the action in here that we're trying to create and drive with the inclusion of this collider in my 3D scene? What's going to be its function? Why did I add this collider? It's my depth zone, and more importantly, since it's a collider, it can understand when things touch it. Okay? When something passes through that collider, the Unity game engine is going to be able to register that and remember that and log it inside of its internal database. So let's test to see if a collision actually happens. Okay? Now last week we went through some scripting that allowed us to very quickly start prototyping and plugging all this stuff together. What's a great way for us to test to see if a collision event is actually generating or is actually being generated? Say again? Play a game? Yeah, but you know, that's playing the game that's a step in the right direction, but I want some direct feedback. I get indirect feedback that I'm touching a collider just by jumping off my plane, but I want to know precisely when a collider has been touched. The console, right. We can send some information to the console. We can use that infamous debug.log command to start generating some information and telling us directly when certain events have been fired off. Now this is a really important idea for me specifically, because I always test a script or test the moving parts of my script before I advance into the advanced creation stage of the scripting kind of area. So let's do it real fast. And there's one thing that I neglected to do on my collider, and I forgot to enable isTrigger, right? Because now when isTrigger is turned on, that collision event is going to be registered, right? The computer will remember when my first-person controller prefab cruises right through that collider. All right, so scripts. I'm recycling some stuff that we worked on last week. Here, let's just delete those. Oops. Okay, there we go. All right. So this is one of the conventions that I use all the time inside of my project directory. This is just for me. It's just the way I work. I like to keep my stuff as organized as I can. So I almost always put a folder at the top, or I always create a folder inside of my project directory that's called scripts. If you look very directly here, why did I put an underscore as the first character of the folder name? To bring it up to the top, because this list is going to be alphabetized. If you look very carefully, I got blue, def zone, door jam, E, F, F, and it's alphabetized, right? There are certain folders that I want to have direct access to, kind of top-level access. So putting an underscore forces them to go to the top. It's a good little power user trick to keep things rocking and rolling. So if you have a folder selected, anything that you create will automatically be placed in that folder upon creation. Let me show you what we're talking about. So as we did last week, we're going to start simply with JavaScript, and then we'll advance and graduate into C# as we get closer to the end of the semester. And let's just call this Death Zone Controller. Okay. Now notice how I'm naming my script here. For those that were here last week, or for those that watched the live stream, what is this naming convention called? Case. Yeah, you got it. Camel case, right? The first letter of the first word is lowercase, and the first letter of each subsequent word is uppercase. What don't you see in there? Spaces. Okay? No spaces in the name of our scripts. Okay? A space in the larger programming structure can mean many different things given the programming language that we're using. If this was like Apache, for example, a space would tell the computer that this is the beginning of the next object in the file hierarchy. Okay, so spaces are kind of, they can mean different things in different programming languages. So just generally speaking, we try not to use them in the naming conventions of our scripts. Okay, so let's go ahead and let's start working with it. If you double click on it, it's going to open that script in our scripting environment called MonoDevelop. It's a beast. MonoDevelop slowly opens the first time, every single time. You can see it just bouncing down in my dock there. It's a big program because it's loading a tremendous amount of information upon launch, okay? So be patient with it. It's not uncommon for it to bounce probably 30 or 40 times before the application initializes. There we go.
Is that something that comes pre-packed?
It does. It comes with Unity. Yep, you got it. All right. Here we go. And here we go. Awesome. So if you look very carefully, the death zone controller.js script has been loaded. So this is the default of what every JavaScript looks like. Now, these functions are important. They're little briefcases. They tell the computer to evaluate certain lines of code and to execute certain commands at very specific times during our game. Some have defined roles like function start and function update. Anything that's inside of the start function is going to be executed when? When you start the game, right? When you hit that little play button, anything that's inside that briefcase is going to get fired off. Now, the update function is pretty special. When is the update function evaluated? Always. You got it. Yeah. The update function, or the contents of the update function, are evaluated at every single cycle of the game, okay? And the game cycle runs at like 2,000 times a second, right? It's not like a frame rate. It's different. It's a refresh cycle rate, okay? So I always think of these functions like questions. In the update function, a question is always being asked, right? In the start function, it's only being asked one time when we hit the play button, okay? So the update function is a good place for us to place commands or questions that need to be evaluated all the time, like a key press. We always want the computer to be listening for when we hit a key, right? Okay, let's jump in and start building our first little script, okay? And hold on a second, I navigated away from my little notes over here. There we go. Okay. So we need to ask the computer to do some very specific things for us. We don't want the computer to, on this script, to be doing anything at the beginning of the game, nor do we want it to be asking a question every single time or every single cycle of the game. We want the computer on this specific script to be looking for a trigger event, to be looking for a collision. That's the only thing that we want it to do. Let's delete those lines of code and start writing the function that we're going to need to get the computer to understand that a collision event has happened. So, of course, in JavaScript, every function begins with a general kind of descriptor. This is a function. Okay, so we always define that we're writing a function with the word function. And then this comes from the Unity code library. On trigger enter. Okay, that's the name of the function. On trigger enter is known by Unity. It's an understood function, so there's a whole bunch of stuff going on in the back end of the Unity code library that's driving this function. And then, once we name our function, if we go back to last week, what comes next? Because there's a consistent kind of convention, a structure in how we write all functions. We declare it, we name it, then what? Yeah. So what's next after this is that we have an open and close parentheses. Okay. This is a rule, by the way. We have to have it. These parentheses allow us to send variables and arguments into this function. More on that much later. Okay. It's a way to send and receive information between functions. It's pretty cool. But after our open and close parentheses, we define the beginning and the end of our function with what? Say again? Almost. A semicolon defines the end of a command. The beginning and the end of a function is denoted by an open curly brace. Then I go down a couple lines and do a closed curly brace. Okay? So between the curly braces is where we're going to be putting all the commands that we want this function to evaluate, specifically what we want it to do. Now you're going to see a lot of folks tend or choose to write this structure a little bit differently. I like doing this. This is just for me, okay? Because then I can see very clearly at the front of lines 4 and 6 here, the beginning and the end of my function. Okay, I like that, but that just makes sense for my brain. Okay, so now that we've defined the start and stop of our function, let's write some line of code in here that physically creates an action, right? This is where we're physically going to do something, and I always tab over to give me a little bit more of a white space. Creating a visual hierarchy within your scripts is a really great idea. It makes it very, very readable. So let's do this. Let's ask the computer to give us some feedback whether or not we've honestly passed through this this collider. So good old classic debug dot log, and then parentheses, semicolon. Okay? The semicolon is the conclusion of a command. So think of these commands like thoughts. At the conclusion of a thought, we tell the computer that we're done with a semicolon. Okay? Now, we need to tell, this is just going to print some information. That's all it's going to do. It's going to put a little word or a string, a sentence if you'd like, inside of our console. So what we want to go inside of our console and to be printed into our console goes inside our parentheses. And of course, we had to have a couple quotes in there. There we go. All right. So you pass through the trigger. If we've successfully made a trigger event, this line of text should show up inside of our console. Now that's all we're going to do for the moment. Let's save our script file save, okay? And return back to Unity and take a look at what we need to do next. Now, if you look carefully, the console is presenting us with some information. We see it down at the bottom of our Unity frame, okay? And we also see this compiler error, the stop sign with the exclamation point in the console itself. Okay, this is a hard stop. Whenever we see a red stop sign with an exclamation point in it, that's the computer saying something is massively wrong, and I'm not going to allow you to play the game, or something's going to be majorly broken until you fix this. Now these little bugs are nothing to be afraid of, but we just got to know how to manage them. And luckily for us, MonoDevelop paired with Unity gives us some really great direct information as to where this bug is and what script it's currently associated with. So if you read the error that's been given to us, it says assets_scripts, defZoneController.js. Look at this. 5,15. What do you think that is? Line 5. You got it. So it's telling us directly where the error is, or where in the evaluation of the script it's kind of stopped and said, problem. Okay? So on line 5, there's an issue. Okay? Log is not a member of the Unity engine.debug. Did you mean capitalized log? Here's the other cool thing that a lot of folks tend to forget about working with these things. If you simply double click on it, it will take you to the line of code where the problem resides. And I did this intentionally to kind of prove the point. We just need to capitalize log, and now we're on our way. Now we've got to save our script. We'll jump back over into Unity for a second, and now that error goes away, and we're free to play our game. Okay, let's go and start playing here. Read my notes. Whee! Okay, so did anything happen? No, not a single thing happened. Why not? Yeah, because a script needs to be a component of a game object that's currently inside of our scene hierarchy. So writing the script is not enough. I wrote it, but I didn't attach it to anything. And this is often a stumbling block for a lot of folks. They forget to attach their scripts to an existing game object inside of our scene hierarchy. So let's do it. So what object are we going to attach this script to? Yeah, the death zone, okay? The death zone. So this isn't going to be associated with the character. It's going to be associated with the death zone. Now there's a couple different ways that we can make this association. Here's the death zone game object. You're more than welcome to encourage to drag it from your project tab over onto the inspector. That works. That's a great way of working, okay? In addition, a script is just a component, all right? So we can do add component, scripts, and there it is. And look at what Unity is doing, because it's just a smart little guy, isn't it? Check out what Unity is doing. Remember how I physically wrote the name of that script in the project tab, right? What naming convention and structure did I employ? Camel case, right? With the first letter of the first word was lowercase, and then the first letter of each subsequent word was uppercase, and there's no spaces. But how is it showing up inside of Unity? Yeah, Unity's a smart game engine. It's going to help us out as much as it can, all right? That works too, okay? So now let's play our game. We've made an association between the script and a game object. Let's see what happens. I'm just going to run off the cliff here. Whoa, wonderful. Mission accomplished. Now it's going to be kind of hard for me. I can't do it at the moment. But check it out. You passed through the trigger. Woo! Congratulations. We've now generated a collision. We've created some feedback between the gamer and the level itself. These little debug.logs are a great way for us to very quickly prototype. Okay? We prototype, we test, we evaluate, and then we expand. All right. So now that we've proved beyond any reasonable doubt that this function is working, let's expand it a little bit. And let's give it a little bit more, and I hate to say this, a little bit more functionality. Okay? Because right now it's just printing something to the console. It's not actually sending information out there into the real world. And let's just jump in and do this real fast. I don't need that line of code anymore, so I'm going to delete it. And this is what I'm going to do. I'm going to go in and I'm going to create an argument that's going to go inside the parentheses. And this is just going to allow us to capture some collision information into a word. We're going to create a variable called other. And this is honestly, it's just a variable. It's just a name. However, if we add a colon in there, we can data type this variable to just collider information. So what we're doing in this moment is we're creating a word, and we're saying anytime there's collision information that's created, I want you to store that information in the word other. It's like a small little bucket, okay? We're putting collision information inside the bucket that's called other. Now, since we've distilled all this wonderful collision information into a word, instead of asking the computer to grab all the collision information, we can just grab that one word, okay? We take some complex information and we distill it down into a single word. We're going to use these variables often, okay? All right, so now what we want to do in our on-trigger render is that we're going to grab any sort of collider information, okay? So anytime something passes through this def zone, collision information is going to be collected and put in the word other. Well, let's do something with that, right? So we're going to do other game object. Okay. Oops. And please note that I'm lowercasing game object. When it's a lowercase, it's some other game object. If it's an uppercase, it's me, the def zone. Okay? And that's how I kind of, in my imagination, kind of put all this stuff together. It's either, okay, is it my collision information or is it someone else's collision information? If it's someone else's collision information, it's a lowercase g. If it's my collision information, it's an uppercase g. Okay?
My is the controller.
Yeah, the def zone controller. Okay. You got it. Yes, sir.
So for the one question about how to make a platform that disappears as a person walks on it, just say destroy this game object.
You got it. And we can get very specific. Yeah. Yeah, if we, yeah. Mm-hmm. Yep. Yeah, we can just destroy me or destroy something else. Okay. So now what are we going to do? So now we're going to send a message. We're going to broadcast a signal inside of our scene. Send message, and oops, I hit the wrong keys just there. So that's the command. We're going to send a message. We're going to broadcast the signal out into the universe a little bit and use that broadcast to drive the death of our character. Okay? Well, what message are we going to send? That's what's going to go inside of our parentheses here. Specifically, there's two things that we need to load into the parentheses. Specifically, the message that we're going to broadcast to our world, and some conditions. And this condition is going to be, hey, I don't need any sort of message sent back to me. It's just going to be a one-way conversation. I'm just going to shout this from the rooftops. So, what's the message? Well, I'm going to put mine as on death, not death. On death. That's the message we're going to send. And then I'm going to ask the computer, send message options. Don't require, require I before E. Here we go. I except after C. I should know better. There we go. So send message options don't require receiver. That's a return signal. Okay? All right, then we end that entire line of command with a semicolon. Let's do this. Since we're here, let's do another debug. And what I'm going to put in here is message sent. Okay? Now the reason I'm doing a debug in here is just to test to see if we get to this line of code. Computers are pretty simple machines if you take a step back and look at it fundamentally. They're just going to follow instructions, and they're renowned for following a very specific order of operations, right? They're going to evaluate things, in sequence. So once we pass through our trigger, what's the first thing this function is going to do for us? It's going to send the message, right? And the second thing it's going to do is going to write that debug log. We can prove pretty directly that this whole thing is working if it gets to debug log, okay? If it gets down to line 6 and it prints message sent, we know that it sent the message correctly and it's actually evaluating that 6th line of code. Make sense? It's kind of a nice kind of proof, some nice visual feedback that it is in fact working. Let's save the script, return to Unity, and see if we have any compiler errors in our console. Yeah, all right, no errors. And I do this pretty frequently, by the way. I clear all the messages in my console. All right, so let's just run off the cliff again, see what we get. Woo, I'm going to go backwards right now. I'll watch my console. Yes, it says down here in the lower left-hand corner of my application frame, mission sent. That means it sent the message, right? It broadcast that on death message, and then it got to line 6 and wrote that little debug.log to my console. All right, so things are starting to prototype exactly the way I want them to do. But now let's do something, right? Because all we're doing is sending a message. Let's actually receive that message and drive some sort of functionality for our player. This enters the creation of our second script, right? Remember this from last week? We had one script for our death zone, another script for that was going to be placed on the character controller, right? This second script is going to be responsible for really receiving that message and doing something from it, okay? So we're going to make a second script here. So create, let's select my script folder, JavaScript. I'm going to call this one, let's just do, character controller. There we go, character controller. Let's double click on it, load it in. Start playing around with what we needed to do. Okay, so if you take a step back and look at what we're trying to drive here and what we're trying to create, we're trying to create some sort of engine, if you will, that determines where inside of our scene our character is going to be placed or spawned once it passes through that death zone, right? That's what we're after. So how are we going to decide that? We need to figure out a specific location for where this player is going to go, okay? Well, I don't like specifics. I try to write all my code in a way that gives me a tremendous amount of flexibility, but we still need to change our character's position. That's a big thing. So let's do this. Let's start off. Now, we don't need the update function, so let's write a new function called function spawn. Okay? Now the purpose of this, parentheses, open curly brace, close curly brace. Now the purpose of this function is to physically tell the computer where we want our gamer to go once it passes through that depth zone collider, right? That's all we're doing here. We're just trying to find a location inside of the scene to place the character, okay? So here's how we're going to write the code. We're going to go transform dot position. Now, if you think about it, what are we accessing programmatically here when we write transform dot position? And specifically the location of our character, right? The position of our character. To get a little bit more specific, check it out. Let's jump back into Unity just temporarily so we can understand kind of conceptually what's going on here, right? So if I grab my first-person controller prefab, every game object is going to come with a transform component. It has to, right? Because this transform component defines inside of our three-dimensional space its location, its rotation, and scale. When we write transform.position, we're telling the computer, access the transform component, and then what series of channels? Yep. Yeah, so right now, when we write transform.position inside of our script, we're telling the computer to grab the transform channel, the transform component of whatever game object the script is associated with, right? And then more specifically, I need you to go in and grab all the position information, okay? So we're telling the computer to set and access this line right here. Transform.position. Yeah. No, it's okay.
What I understand is like the 1.89, is that one unit off of the y-axis?
You got it. Yeah, of the origin.
So,
yeah.
Right. So it's like 1 and 8.9 of another.
Yep.
Okay.
Yeah. So what are we going to do with that? Now that we know what we're accessing programmatically here, we need to go in and change it a little bit, okay? The whole idea here is that we change the location of our player when he passes through that depth zone, okay? So I'm going to put a single equal sign in there, and that's an important thing. A single equal sign is going to set or change a value, okay? A double equal sign is going to act as a comparison moment, right? We're not comparing numbers, we're changing it, okay? So what do we want to change this the location to? I don't know. Yeah, I don't want to go in and figure out numbers. I don't do numbers.
Where your original spawn point is?
Yeah, and maybe the best, yeah, we need to figure out some sort of new location, right? Where's that new location? I don't know. I don't know what that number is, right? I need to go in and figure out some sort of vector 3, an x, y, z coordinate for where I want my computer to place the gamer. I don't know those numbers, nor do I really care what those numbers are. I think what I'm most interested in doing is writing the script in a way that allows me to interactively change those numbers in the editor. Okay? So here's what I'm going to do. I'm going to create a variable. Okay? Specifically, I'm going to create what's called a public variable. And we define each variable with the word var. Var, unsurprisingly, for variable. Okay? And what this is going to be, I'm going to call this spawn point. Okay? So that's just a name, it's just a word. It could be, Pat's spawn point. It could be Mickey Mouse's left hand. It doesn't matter. It's just a word. But this word needs to have some meaning behind it. Well, let's give it some meaning. Let's data type. So let's assign this word to only exclusively accept certain information. The information we want it to be data type to, and I'm doing that with a colon, by the way, is transform information. I think once you see the conclusion of this here in a second, you'll kind of go, oh, I get it, okay? Because this is going to take on a new light. I'm going to cough for a second. Excuse me. All right. So what we're doing here when we write the word transform is that we're creating an empty container. Since there's a public variable, this empty container is going to show up in the inspector, and you'll see this in action here in a second, okay? So just hang tight. And then in the inspector, we'll be able to load some values in. I don't want to have to go in and change, hard code in a location, because that truncates our game designers, you guys, it truncates our game designers' ability to change the location. right, interactively, quickly. We shouldn't have to go back to the programmer every single time just to change, a simple value like the location of a spawn. All right, so now what I want to do is I want to copy that variable's name, just Command-C, and load it in. And I want to say, hey, I want you to grab the spawn points position. Yeah. So we're going to change the player's position to whatever the spawn points position is. Okay? So let's save it. That's the next step. Yeah, let's save it real fast and travel back over into Unity and start making these connections. Now, on my first-person controller prefab, let's go ahead and add that script in here. There it is. Okay. Aha, wonderful. Look, check it out. See how that spawn point variable has now been exposed in the editor itself, in the inspector, and it can accept a game object. Okay. You can accept the transform component of an existing game object. So let's do this. I'm going to create another empty game object, and I'm going to call this one uncreatively spawn point. Okay? And where do I want my character to go the moment he dies? How about, I don't know, over here. That's good. Here, we'll do this. We'll put him right back in front of the cube. There we go. So the spawn point, this is just a locator, basically. And specifically, by moving it interactively around in our editor, we're capturing this detail, this line, this entire row here. Okay? So what this allows us to do now, since we have a game object that defines the location that we want to spawn to, is that I can take this game object and drop it into the inspector over on my script. So now we're loading this game object's location as the variable information in the inspector over here. Okay? Does that make sense? Yeah, go ahead.
So if you have just an interesting example of a spawn in the new Ubisoft Wildlands, I didn't put the final release, but the beta, the camera drops in. Not you, not the player.
The camera.
Drops.
Yeah.
Right? And it's kind of like, it kind of gives you a nice like aerial effect of the world that you're in real fast.
Yeah.
And then it speeds up and like kind of plunk, and there you are to start out with.
Yep.
On the player. How does that work?
I don't know. Yeah. There's a lot going on in that moment to make that entire action happen. But there's a couple things that the computer's going to need to know, right? It's going to need to know that the character has died. It's going to need to know where to place the avatar of the character inside of the scene, where to spawn the camera, where that camera is going to animate to, and then its connection back to the player. There's some things, some objectives that script is going to need to accomplish. How they're choosing to do it is up to the programmer that scripted it.
Maybe like attaching a camera to the controller.
Yeah, I'm sure that's a part of it. Yep. Mm-hmm. Or they may just be animating that camera.
Yeah. Okay.
Yep. All right. All right. So we've made a connection with our script to our first-person controller prefab. We've created a spawn point, which is just an empty game object in the scene, and then we're passing that empty game object's location back into the script by loading it into the variable that we established in our character controller script. Okay. But we really haven't done anything yet, right? We've told the computer where to place our character when we spawn, but we haven't told the computer when to spawn our character, right? Interesting idea. We've told it what to do when it spawns. We haven't told it when to spawn, right? When it actually needs to fire off that function there. So let's do this. I'm going to go back into my game here, and I'm going to grab my first-person controller prefab, and I'm just going to place it way off over there, out in the middle of nowhere, just to kind of prove a point. So now, at the moment, without making a single change, I'm going to start the game, and I'm going to immediately fall. Okay? I don't want that. I want my player to start the game right next to the box, right where this spawn point is currently located. right? Well, let's check this. Let's go back into our script real fast, and let's change it. Okay, we're going to add a new thing in here, and we don't need the function start. We actually there's a couple different functions that are evaluated and fired off the moment the game begins, the moment we hit that play button. Okay, there's function start, there's function await, function awake. There's actually late awake as well. The game isn't starting. The character's role within this game is starting. So let's do this. I like function awake in here. Parentheses, open curly brace, close curly brace. Okay? So what's the first thing we want the computer to do when it starts? Or when the game awakes from its state? Basically when we hit that play button. What's the first thing the computer should do to our character? Spawn it, right? To change its position, to put the player right next to that red box. So we're going to activate and call that function. I'm going to copy it. And here's that it really is as easy as just doing spawn. Okay? It's a function, however, so we have to have an open and close parentheses. And how do we conclude a command? Semicolon. There you go. So now when I save my script, return back to Unity, and play my game, what do you think is going to happen? Bloop. Right next to the box. Okay? Awesome. So it works. The spawn function works, right? Beginning of the game, the player's position is automatically moved and positioned right next to the red box. Exactly what I'm after. Yes, sir. Interesting. Let's check it out. All right, Joe, what computer number are you? 17. Maybe a fresh pair of eyes will help. This happens often. You may have just simply misspelled something or a connection isn't created. Let's just check it out real fast. 17. All right. Aha, okay. Show me your script. You misspelled position. The second one. You went persistent. Yeah. Let's see if it works now. Give it a second. There it is. Now do it. Yeah, this script is now updated. You can drag that spawn point in there. Yep. Yeah, working within the programming kind of art, if you will, humbles you pretty quickly. I was like, oh, I misspelled the. Damn. Yeah, that's why I've been banging my head against this thing for an hour because I misspelled the, right?
It's so easy to spell out T-E-H.
I want to make it so that the spawn point can change each time I hit supplier on a surface that I want them to be able to spawn on.
Yeah, let's wait for that because that actually kind of dovetails into our next conversation about Booleans. So every time they jump on a platform, you want your spawn point to change, right? Yeah? So we need to tell the computer that a state has changed, right? That a flip has been switched. Okay, well, there it is. Yeah, that's fine. Yeah.
But what's happening is I'm trying to make it such that I can do this. So I have to make it so, hey, if they move, 35 distance downward, then they fall off a cliff and must die.
So there's a couple different places that you can go with this, right? We can create enumerated states and capture arrays of data, right? And we can change the contents of a variable based on a state. Or maybe another simple way of doing it is have like 3 different spawn points, right?
I'm setting up all the spawn points.
Yeah.
I just want to make sure I can make it so that if they fall 35 points below that,
Okay.
What's wrong is that it's not doing that.
Yeah.
Yeah.
let's workshop this after or during a break or something. It's not impossible, and I know how to do it, but I don't want to take everyone down a rabbit hole that I don't think maybe not everyone's ready to go yet. Okay, let's keep cruising here. All right, so it's working. There it is. It's next to the cube. Rock and roll. Okay, so let's finish it up with a little bit here, because really there's one component that's missing. And from our conversation last week, what is that one component? Because we've proven that we can change the player's location at the beginning of the game with our custom function called spawn, but it's not calling that function when we pass through that collider, right? Well, let's take advantage of that message that we were sending out from that other script. If you look very carefully in my mono-develop, of course we have my death zone controller script still up and active, and we're broadcasting a message here called on death, okay? Broadcasting it to the world. Well, this is just a word, right? Let's give this word some meaning and write a custom function also called on death, okay? Okay? Wonderful. So when this word,
That's going to receive that broadcast.
yeah, and I was kind of cheating to a certain degree earlier. We're not actually broadcasting a message. Well, we are, but what we're actually doing now that we've written this thing is that we're calling a function on a separate script. Yep. So what do we want the onDeath function to do?
Make flowers.
Make flowers. I love it. Spawn. That's all we wanted to do at this stage, right? So I'll just type in spawn. Now, let's save it. Go back into Unity. Player game. Immediately we should get spawned once it starts. There we go. Spawn next to the red cube. Awesome. And then when I jump over the edge, let's see what it does. Back to the red cube. The moment we touch that collider, we're spawned back at the location of the red cube. Pretty cool, huh? Pretty cool. So that's what we went over last week. The creation of a trigger, which will allow us to pass information from one game object to another, and begin to move and change some of these dynamic elements around inside of our scene. Since I've been going for a couple hours, maybe now is a good time to take maybe a small little 10-minute break. Okay, sound good? Let's take a break. Okay. So we spent some time talking about the just kind of our basic scripting structure, a little bit of a review from last week. We're starting to send information from one thing, from one game object into another, and the information that we're sending is physically driving an action inside the game itself. Let's take one step further into this, okay? The first thing that I want to kind of go over today is going to be a building block for a much larger conversation. We're going to learn two important things today. One you're going to use often, that's going to be a key press, right? How to drive a function when you hit a key on your keyboard. That's going to be an important component going forward. The second thing, and this is a much larger conversation, is the role and impact of a Boolean, which is basically like a switch. Okay, it allows us to ask a question, consider a condition against that question, and then drive an action based on the answer to that question. Right. It's a really powerful system of our programming language, and we're going to be building on this over the next 3 or 4 weeks. It's that important. Okay, but I want to start kind of setting the foundation for that today. All right, so if we take a step back and look at what I've created, there it is. Of course, here is my simple cube. Okay, let me get rid of my gizmos here. Oh, I don't care. All right, there's my simple cube. I want to be able to go in, and here's the big picture idea. I want to be able to go in and hit a key on my keyboard and change the color of that cube. Okay, so the first part of that is being able to log a key press, and drive an action based off of my ability to hit, like, I don't know, the Q key or something. Okay, so let's take a look at what that looks like. It's pretty easy to start putting that together. We have to consider what game object that this is going to sit on. Since we're driving the function and the action on a cube, it's probably best to put this script on that cube. This cube is going to be listening for a key press. Not everything has to go on that first-person controller prefab. Actually, I would recommend that very few things only go on that first-person controller prefab. Things that only affect the player should go on the character controller. Things that affect other game objects should naturally go on that game object. Okay? So, big picture idea. I want to be able to go in, press a key, change the color of my cube. Okay? Let's do the first component, which is getting that key press up and running. So let's create a new script here real fast, and I'm going to call this, let's see, Pat's Cube Color Controller. Why not? Okay. Let's double click on it, open it up in MonoDevelop, and start writing our code. All right. So as we outlined earlier in the day, there are certain functions that are evaluated at certain points inside of our level. Which of these functions is constantly being evaluated? The update function, okay? So this is a natural home for questions that need to be asked every second of every game, right? And a key press is a question that we always want the computer asking. Did I press the Q key? Did I press the Q key? Is the Q key pressed now, right? We need the computer to always be listening for that question, and then we need to drive that answer. So the update function is a great home for this next command. Now, key presses inside of Unity are pretty easy to create. Let's just make one real fast, okay? And it forces us to start asking a question. Let me change the way I've written this real fast just to make it easier for my brain. So I need to ask a question of the computer. I need to ask if a key press has been enabled, right? So this is going to be our first if statement, which is a question, right? If we've pressed the Q key, then something's going to happen, right? If statements are kind of like little mini functions in themselves, and they get a very similar structure to a much larger function, to the functions that we've already established. So let me illustrate real fast how we write if statements, and they're pretty easy. So as one might imagine, if. But where this begins to get interesting is that naturally we can put, it gets its own parentheses, and check it out. It also gets its own open and close curly brace, okay? As with the larger function, what we ask the computer to do and evaluate is going to go in between those two curly braces, okay? This is a really great example of why we choose to tab everything to create a natural kind of visual hierarchy of all these curly braces, because in very complex scripts, you're going to have nested questions inside of these functions The white space in these tabs will help you stay organized. Okay? All right. So let's figure out what key press we want to do, and then we'll just kind of test it to see if it works by doing a simple debug.log inside of our console. So the question is going to go here in the parentheses, okay? And then and if that condition is met, that's going to go down here, okay? So what do we want to do? Let's do the Q key for whatever reason. I like the Q key because it's right next to the ASWD. So here's how we write a key press, and it's really easy. We're going to do input dot get key down. And if you look at the logic of that, could you also do a get key up? Yep, that's what happens when you let go of a key. And that's nice to have because sometimes people go, oh shit, I didn't want to press that key, right? So it gives people an opportunity to bail out, press another key down before you let that one go, right? Get key down. Now, what's weird about this is that it gets its own series of parentheses, okay? And if you look at this real fast, we have start parentheses for the input.get key down. There's the end parentheses. And then this is where we physically go in and tell which key to press, okay? So we're working with this nested hierarchy of parentheses here, which is kind of strange, okay? All right, and now we say key code, and that's the computer word for the actual key. And then we do period. Oh, and the C in code is capitalized. Many apologies. Key code, and I'm going to do the Q key. So if we press the Q key, something's going to happen. Okay? Well, let's define what that function or what that action is going to be. I think I'm simply just going to put a debug log. Oops. You pressed the Q key, exclamation point. Yeah, go ahead.
Why didn't you camel case get key down?
Get key down. That's just not how the code's written. Yeah, that's not how the command's written. Yep.
So camel case is only naming convention.
Naming conventions for just like the script name. Yep.
Right,
Yep.
Okay.
This comes directly from, oops, I apologize. This comes directly from the Unity crew. Yeah, so I don't really have much control over that. All right, so let's test it. Let's see if it works. Let's save the script and associate Pat's cube controller with that little simple cube. So here's my cube. Add component. Scripts. There it is. Let's play the game. Oops, I got an error. It didn't like that. It didn't like my parentheses in there, so let's do that. Or it didn't like my quotes in there. That's my fault. There we go. I always see if the compile error goes away. Let's play the game and see what happens. Now we spawn next to the cube as we normally should. And let's hit the Q key. Wonderful. Because down here in the console, I'm getting the feedback loop that's required to understand that what I've just programmed in is in fact actually working. Hoo-ha! We did it, okay? We've pressed a key, we've registered an event, and we've given us as the editor here, as the author, some feedback that that event has been evaluated correctly. All right. Wonderful. So now let's build upon this idea for a second, okay? Because we want this key press to do something a little bit more, okay? A little bit more, some heavy lifting in here, okay? What if we get this key press to change the color of our cube? Okay, now this is kind of fun. You see this all over the place in the game world, right? Where you walk up to a door, you hit a button, and then all of a sudden the button goes from red to green, signifying that maybe the gate's open or something like that. Colors change often, and we don't want to rely upon a JPEG texture to drive the color of every single thing inside of our game, right? Sometimes just changing the material's color is enough, right? And the cool thing about using materials in Unity is that all of those channels are exposed to us programmatically, right? And now we just need to figure out how we can go in and access those material colors with some code, okay? So the first thing that we have to do, and this is where, admittedly, it gets a little strange. The first thing that we have to do is go in and grab the rendering engine. Okay? Oops, excuse me, my tooltip highlight kind of got in the way. All right? So we need to go in and ask our little script here to access the entire rendering engine. Okay? Actually, the entire instance of the rendering engine for this local object. Okay? We're kind of saying, okay, render the part of the rendering engine that's just drawing my cube. I want to talk to you. Okay? It's a little strange. Okay? And here's what we're going to do. We're going to do this a lot, actually. So the first thing that we're going to do, we're going to create a variable. We're going to call this variable, I'm going to call it my color, just because I want to. Okay? And I want to data type this to the renderer. Okay? And please note that I'm doing renderer. It's not just render, it's renderer. So with the ER on the end. Okay? So we're capturing all this rendering information and we're putting it in a word, and I've just named that word my color. Okay? This could be anything. I'm just doing my color just because it makes sense to me. All right? Well, we got to go in and load my color with some information right now, because right now it's just a word. We've told it it's going to be rendering information, but we haven't loaded any information into that word. So let's do it, right? And this is the first thing I want my computer to do when it wakes up. So I'm going to say my color. Okay, I'm going to load you with some information here. Pop quiz, hotshots. What does a single equal sign mean? Set value. Okay, so we're setting this variable to something. We're changing its meaning. We're changing the data that's inside of this little capsule at the moment. Okay, and this is this part that's weird because we need to tell the computer to go get the component. Okay, so get component. And this comes from the Unity folks. I actually had to look this up because my code was old, and with the new standard shader, this is up and updated. Okay. Yeah.
Is there a list of like where we can go to find like?
You read my notes, and we're going to come back to that. And the answer to your question is yes, and it's very easy to find this list. Yeah, because it's overwhelming, and even I don't know where this list is, or I don't know what all this stuff is, right? But it's important to know where to find it, and we're going to get to that in a second. Okay. Yeah. So we're going to do get component dot, and then we got to do Then we got to do some carets in here. Okay. And this is where I messed up earlier. While you guys were taking a break, I was prototyping this. Okay, get component, and now we're telling the computer get the renderer, get the instance of the rendering engine that's physically responsible for shading my cube. Okay, so we're loading all of that renderer information into this variable called my color. Okay. Well, now that we've loaded it, and this is why I put it in the start function in the script. So the first thing it does, it goes it grabs all that information and it puts it in that word. Okay? Well, now let's do something with that information. I don't want to press a key anymore. I want to go in and start changing that color information. So I'm going to do my color. Okay? So I'm grabbing all the renderer information now, and I'm going to say, hey, I want to access specifically the material that's on my cube and the color channels. And once again, we're going to set it. Okay. Well, what are we going to set it to? You could go in and, if you look at the way that the code's written, color is defined numerically. Okay, so we can get very specific if you wanted to have it be a lovely shade of chartreuse or maybe a plum color. You can figure out what that color means numerically. However, I don't want to do that. I don't care about chartreuse and plum. I think I want to just use some basic simple colors like red, green, blue. Luckily for us, the guys down at Unity have done us a favor, and they've kind of in the actual code library itself, they've created some shortcuts that kind of give us a basic, shortcut, if you will, as to what these colors are represented as inside of our code. And really, that's all we're going to do: color.blue. And to answer the question that's probably bubbling in your mind, if I wanted it to be green, yeah, it understands what green is. I think the renderer knows it, just by the word what red, green, blue, yellow, black, and white is. Or, you know, we don't have to go in and actually type the number values are in there, which is kind of nice. All right, so I'm changing. Let's go over the logic of this. I've created a variable, okay, a container that I'm going to store rendering information in. When I start my game, I'm going to grab that variable and then physically store the rendering information in there, okay? If we don't load information into the variable, it's just a word, right? A word without meaning, a word without data. At the beginning of the game, we load that word full of render information. And then we access that rendering information down here in the if statement. We say grab all that rendering information, and then specifically, because we're in getComponent.renderer, we're grabbing everything. Everything that's responsible for shading and rendering this cube. Well, I don't want to work with everything. I want to work with just the material, and then specifically, just the color values on that material. And I'm going to set them to green. Make sense? Okay, let's see if it works. Let me save my script. Yeah. Oops. I think I made a mistake. Get component. Okay, I messed up clearly. Hold on a sec. My color, get component. Oh, I forgot that's my fault. I forgot the open and close parentheses in there. There we go. I'm glad I witnessed that mistake because I have to change. It's after the caret. Great. Okay. Let me update my notes as well. No, it was in there. I just didn't. I had it in my notes. I just refused to see it in my notes. I'm a dork. My brain's getting mushy at the end of the day. Okay, let's save it. Go back into Unity, because now that should be removed. Excellent. Let's go back into the game. And since we applied it to everything, let's hit the Q key. Bloop, turns green. Awesome sauce. It works. Okay? However, hit the Q key again. Yeah, I can see people doing it. What's not happening when we hit the Q key? It's not flipping back, okay? Not surprisingly, because we haven't told it to flip back, okay? Here's what I want to do. I want to create a system that allows me to flip back and forth, going from red to green, red to green, red to green, based on the key press that I've established inside of my script, okay? In order for us to do this, we need to create a condition, okay? We need to create a state. A true-false statement, okay, that allows the computer to drive an action based on the answer to that true-false statement. That's what a Boolean is. It's a true-false statement. It's either on or off. It's either true or false. It's either a 1 or a 0. The more we distill these complex logic streams into on and off, ones and zeros, trues and false, believe it or not, programming gets a little bit more easy, okay? Let's take a look at what this is going to look like physically inside of the script itself. Okay, I love Booleans. I think Booleans are a great way to program. There are definitely more advanced structures that we can create, but Booleans at the low level just allow us to ask a simple question: is the condition true or false? If it is true, do this. If it's false, do this. Okay, it really is, or really allows us to expand the details of our if statements, because now we're creating if-else statements, right? All right, let's do it. Should we get in there? Ready to start working? It's going to be pretty easy, okay? So the first thing that we need to create here is the actual Boolean itself. Booleans are almost always variables, okay? Variables that we check against, okay? Let's define our variable, and I think I'm just going to call it my Boolean. Why not? Not Coolean, although it could be Coolean. I typed the wrong letter there. Okay. All right, and let's data type it, okay, to, unsurprisingly, a Boolean, okay? Now, Booleans, as I mentioned just a minute ago, are either true or false, on or off, ones or zeros. Another way to think of a Boolean is like a light switch. The switch is either flipped, it's either up or it's down, right? So we could just end our definition of our Boolean like that. This just creates one. But it's a good practice to create an initial state of our Boolean, okay? I'm just going to put true in here. Oops. So we're creating a Boolean. We're going to call it my Boolean. And we're also going to initially call it, or we're initially going to change its state to true. So it's on by default, okay? Now, if we didn't do this, the first thing that we'd have to do on function start is to change its value to something, right? We always have to create an initial state for a Boolean. I'm doing it upon creation, okay? If some people like doing this, and this is a good way of working, but you don't have to do this, right? Is on start, you do my Boolean is equal to true. Not. There we go. That works the same thing. It's the first thing that the computer does is it changes our Boolean state to true. Okay? 6 to 1, half dozen to another. I'll go back to what we had it a second ago just to be consistent. Okay. So now let's do something with this. Okay? All right. So since our initial state of our Boolean is true, since the switch is on, we really want to check against it, right? We want to ask, is it false? Is it true? Right? If it's false, do this. If it's true, do this. Okay? So what we're going to do here is create another kind of a nested if statement. Because this one, okay, does what? What's this if statement doing, or if question doing? Yeah, and specifically, it's asking, did we press a key? Okay? If we pressed a key, do something. Okay? Now we're going to be doing two things. We're going to say, did we press a key? And is our Boolean true? Okay? Because if it's false, because really what this allows us to generate is that false component as well, okay? All right. All right. Hold on 2 seconds. I want to make sure I'm reading my notes correctly. Okay, so let's do it real fast. It's quite easy, okay? However, this is where, we get a lot of these curly braces in there, so I apologize. Okay, so these curly braces, in every sense, establish the structure for our first if statement. Well, this is the command that we're going to fire off. We don't want to fire it off quite yet, okay? So here's what we're going to do, okay? I want to change a couple things here just to make my brain understand this a little bit more directly. So I'm seeing here the error of my way. There we go, Pat. That's better. Yeah. It's all about making sure my brain is understanding specifically what it's asking to do. Bloop, 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 close, close. Okay, cool. So let's set the structure of all of our open and closed curly brackets first, and then we can go back in and start loading some stuff in, right? So instead of doing my color, now we're going to ask another if statement, okay? If, then it gets its own set of curly braces. Okay. Now we want our action to be driven upon the resolution of that second condition. So analyze the structure of our curly braces. This first set on 10 and 19, that's for the function, okay? The second set on 12 and 18, that's for the key press. And the third set on 14 and 16 are for this second if statement, okay? think this is a real great visualization of the importance of the tabs and the white space that we're generating inside of the scene. Okay?
So do you need to do now an if statement for if it's red?
No, not yet. Not yet. That's gonna be something else. We're gonna get back to that. Okay? We're just gonna do this one just so everyone's on the same page, and then we'll do the else statement, right? Because we're gonna flip it to green, but then we also have, because you're red, we also have to have something that flips it back to red. Okay? All right. All right. So now we gotta say, okay, in this if one, we gotta ask if my Boolean is true. Okay? So if my Boolean is true, and it's all we need to do, right? Okay. When we say my Boolean, we're assuming that the value is true. Okay. If it's true, we're going to change the color to green. Okay. Now, do you want to try it, see if it works? Yeah? Let's save it. Let's go back into Unity. Fingers crossed. Ah, awesome. I apologize for pausing. Okay. If my Boolean is true, you press the key, the Q key, it goes to green. Awesome. So if it goes green, that's your indication that you've met both conditions, right? You've pressed the key, which is the first if statement, and the Boolean switch has been enabled, it's been on, it goes green. If it doesn't do anything, we've messed up. I'll put this script back on the screen here.
What do you do if you press what is it?
Say again?
If you press it again, what is it?
Same thing. Same thing. We haven't created the switch yet. So in essence, we're setting up for the switch, but we haven't created it yet. Okay? So here's the script. And like last week, I'm going to be providing this script to you guys on Canvas too, so don't feel like you have to feverishly, copy and paste all this stuff. Yeah. Although it is good to practice. I think you make a pretty direct general connection to the stuff that you're writing when you actually write it. For me, pieces are, wires are forged and connections are created when I start physically writing it down. Even when I have the ability to copy and paste stuff, I still choose to write it out just so I can start remembering it a little bit more directly. All right. Everyone with me? We're good? All right. So here's what we need to do. In order for the switch to work, we have to change the state of my Boolean, right? So here's what we're going to do. The moment so if the Boolean's true, fire a color off. We also need to change our state back to false, so we can hit the Q key again and ask it to change the color, okay? So here's what I'm going to do. I'm going to go in and say, hey, my Boolean, I'm going to set you to false, okay? Whenever we flip a switch, whenever we flip the switch to on, we have to immediately put it back to off, or there has to be something in there that turns it to false, okay? So let's walk through the logic, okay? If I hit the Q key, and if my Boolean is true, which it is, because it's initially set to true, change the Boolean to false, and also change the color to green. End of line, okay? So the question is, how in the world are we going to get it back to a different color, right? Because there's nothing in here that physically drives the color of all this.
Didn't you just change that?
I didn't change the color. I changed the Boolean back.
But if the Boolean is false, then by that logic, it would have to...
Not yet. Not yet. Because there needs to be a comparative statement in here that's going to change it back to a different color. We need to define false. Right. Well, not so much false. We need to create a condition that checks against whether or not the Boolean is true or false. Okay? That's what we're doing. So if, now the last thing in here, and this is where it gets fun, and please note that here's the if statement. Okay? Yeah, Nathan, go ahead. On line 3? I did. Thank you so much. Thank you. I can't chew gum and walk at the same time. Okay, so please note, this is the if statement. Okay? If my Boolean is true, set my Boolean to false. Okay? Flip the switch back down, then change the color of my cube to green. On that same indentation level, okay? It's going to go down, okay? And now I'm going to do else. On else is a little different because we don't need to check against the state of our Boolean, okay? We just need to define the opposite condition, okay? So in order to do that, we just have open curly brace, close curly brace. This is another great visualization of the importance of hitting the tab key and organizing these curly braces, because you're going to get confused as to what level you're working within if you don't. So if it's true, make it green. If it's not true, what are we going to do? Make it red. However, we also, in order for us to continue hitting this flip switch over and over and over again, we also have to, in case it's false, we also have to set the Boolean to true. So what we're doing here is we're saying, hey, if it's true, do this. However, if it's not true, if it's false, make it true and change it to red. It's a simple switch. If else. Question?
Yeah. So we know how to do that.
Mm-hmm.
But our user doesn't.
Say again?
Our user doesn't know how to do that.
Hit the Q key?
Well, if they don't know that it's there.
Yeah, we'll have to figure out some way to communicate to that to them. Yeah.
Like, so, I mean,
Yeah.
They're giving me, so how would you attach? And they're like, walk up and press Q.
Yeah.
Kind of like where you see like the Q button or something.
Yeah, absolutely. We can draw that information on screen. I mean, there's 1,000 ways. You can start off with an opening graphic that provides all the instructions. I remember someone, I think, a simple solution, hit a signpost. The first thing you see when you start your level is a signpost, and it said Q equals action key. The space bar. There's 1,000 ways to communicate that information to the user. As the designer, you got to figure that out. Nathan, any question? No. I think it's a numerical value because it gets broken down into the R, G, and B channels. 0 to 255 within each one of those channels, just like the way Photoshop kind of defines a color value. All right, let's test this out real fast. Let's save it. Let's go back over into Unity. Looks like we're not going to get any compiling errors. Yaha, roger that. Let's see if it works. Okay. Hit the Q key, it goes green. Hit the Q key again, it goes red. So we've successfully made the switch. Okay. And now, because of that switch, because we're always evaluating whether or not the switch is on or off, we can hit the Q key until the cows come home, and it's always going to flip back and forth. Okay? Let's return to the script real fast, because the logic behind the Boolean switch is really the most important part. Okay? We're saying, if it's true, make it false, and then change the color to green. Okay? However, if it's false, make it true, then change it to red. Okay? There always has to be something inside the script that understands the false statement as well. Because it's, the first time we hit the Q key, the Boolean goes to false, right? Well, the next time we hit the Q key, we have to ask this little question here. Okay, if it's false, then do what? Okay? Because that state is going to be persistent until the next time the question's asked, right? The state doesn't change until we hit the Q key again. Does that make sense? The question, the Boolean stays in that current state until we hit the Q key again. Okay.
So how do we swap this like with the player controller and the collider?
That's a good question, right? So the question was, how do we take this structure and we use it for a collider, right?
Like make the collider and the player the switch.
Yeah, you got it. So let's think about the logic behind that, right? Instead of doing a key press, we're doing an on trigger enter. So it's not if input.get key press. It's function update if, I don't remember the line of code, but we can actually capture the collision information. Okay? It says if the player collides with me, do this. Else, do that. Yep.
Cool.
We'll go into that. That's the next stage of this, right? That's the next step of this, is getting it to work. Because this is how we do like doors and stuff, right? You walk up to a door, it opens, right? You walk away from the door, it closes. It closes. This is how we start to test if a player has picked up something, believe it or not. If you walk into an object, you're going to destroy the object and kind of set that state to true. I have weapon, right? True or false statements. That's all we're trying to define here. Okay? And we're going to use these all over the place.
Can we set a distance for player interaction with it?
Yeah, absolutely. Absolutely. You can start doing some research on it. It's called ray casting. It fires off a little invisible line in front of you, a defined distance. And if that ray interacts with something inside of your scene, a condition will be hit. Yep. And then the question you ask is not if input, is if ray cast hit. If my little ray hits something, do something else. Yeah. Another way people do doors, right? Because you can localize that ray to the player. One of the problems that you see in a lot of games, especially that has like a lot of enemy AI, if it's just any sort of collision, an enemy zombie walking past the door will generate collision. The zombie will open the door instead of the player opening the door, right? So a raycast is a great way to localize that collision and that capturing of the collision information to the player. Because then it's just that one thing that's firing off the collision information, or that's firing off the switch. Pretty cool, huh? Pretty cool. Yeah, we're going to be using Booleans all over the place, and I wanted to introduce it pretty early on because it's going to be a foundation that we continue to build upon pretty much for the rest of the semester. This is going to come home to roost when we start talking about animation events, right? Because the entire animation system is built around the idea of states, true or false statements, okay? And you'll see that in play when we start looking at mechanism. And then maybe next week, probably most likely the week after that. Sound good? All right. Okay, so it's 4:15. Okay, I'm gonna let you guys get out of here. Please remember your homework this week is to make the white boxed prototype of this interior level. Keep it basic, keep it simple, but make it complete. Basic and simple is not an excuse to make it incomplete. Okay, we should see the entirety of the experience in one basic, simple level. Please remember, go in and change the lighting. I saw you guys playing around with it earlier before. That default directional light is going to do a poor job of establishing a good lighting setup for interiors, right? You can change your lights, okay? Just like we can change them over in Modo. Of course, you can go in and add a whole bunch of really great lights. The point light is really good for interiors, okay? Questions about what we're striving to accomplish this week? Everyone good? Awesome. I'll see you guys next week.